afternoon, everyone. I'm Mom Jane, your science teacher. How are you doing today? It's been a rainy and gloomy day for us. I hope you are all doing great. So let's start our lesson. Before we proceed to the lesson proper, let us recall our previous discussion last week. With the consent of Ken's, I'll be presenting to the class his video about what he had learned last week. Let us watch his video.
So this week I've learned about what is a rock, what classifies as a rock, the different types of rocks, the processes that creates a rock, and the different subtypes of these types of rock. So uh, a rock I've learned is anything that is naturally occurring, which is made from minerals or non-mineral materials. So one type of rock that I've learned is igneous rock. An igneous rock is formed when magma or lava solidifies, which can form intrusively or extrusively. Intrusive meaning below the Earth's surface, or extrusively meaning on the Earth's surface. So another type is sedimentary rocks, which are rocks that form from sediment, which are parts from other rocks that weathered or eroded away. So there are five processes that help to create sedimentary rocks. One is erosion, another is weathering, then dissolution, precipitation, and luthification. So there are three types of sedimentary rocks: so plastic, biogenic, and chemically precipitated. Another thing is sedimentary rocks can contain fossils or remains of dead living organisms from many years ago. So another type of rock is the metamorphic rocks, which are rocks that are formed from the process of metamorphism. The metamorphism is the process in which extreme pressure or temperature is present. There are two types of metamorphism. One is regional metamorphism, which is when extreme pressure is present. Another one is contact metamorphism, which is when extreme temperature is present. So there are two types of metamorphic rocks. One is foliated, and the other one is non-foliated. The foliated rocks are metamorphic rocks that are layered, meaning there are layers of metamorphic rocks on top of each other. And non-foliated metamorphic rocks is the exact opposite of the foliated metamorphic rocks, which are rocks that are not layered. So that's all that I've learned this week.
All right. Thank you very much, Ken, for sharing to us what you have learned from our previous discussion. Now, let us proceed to our lesson proper. Our lesson proper will be about ore minerals, how they are found, mined, and processed for human use. We have three objectives for today's lesson. Number one, describe how ore minerals are found. Number two, identify the different mining method. And number three, explain the three steps in mineral processing. I have a question for the class. Is mining important? Is it important to our daily life? I have here a video about mining. Let us watch together, and after watching it, I want you to share your answer to my question. Is mining important? And post it on our Google Classroom so everyone can see your answer. Let us watch the video together.
Is mining important? There are currently over 7 billion people living on planet Earth. And for survival, every human being needs water, food, and shelter. Could modern civilization survive without mining? Let's see. No iron ore mining, then no steel. No limestone mining, no cement. No sand mining or crushed rock mining, no concrete. Without concrete and steel, there would be no skyscrapers, no shopping malls, no supermarkets, no stadiums, no hospitals, no cities. For infrastructure, there would be no roads, no rails, no bridges, no harbors, no airports. And for transportation, there would be no cars, trucks, trains, ships, or planes. Without infrastructure and transportation, there's no local business, no interstate commerce, and no global trade. Without concrete and steel, there would be no dams, no water wells, no water treatment plants, no water pumps, no water towers, no water. And if there were no potash mines and no phosphate mines, there would be no fertilizers. And without agricultural equipment, there would be no crops, no feed for animals, no food for humans. These 6 mines provide the basic commodities for water, food, shelter, and infrastructure. And for everything else, statistics for 86 mineral commodities are reported annually by the U.S. Geological Survey. So is mining important? Without a doubt. Absolutely everything we depend on is either made from minerals or relies on minerals for its production and distribution.
Okay, I will be giving you time to answer my question based on the video. Now, let's proceed to the next one. What is the difference between mineral and ore? Let's watch this video with a short explanation.
In this short video, we are going to discuss about the differences between minerals and ores. The first point which I am going to write is naturally occurring substances of metals present in the earth's crust are called minerals. And for ores, minerals which can be used to obtain the metal profitably are called ores. The next point which I am going to write is all minerals are not ores, but all ores are essentially minerals. Now comes the example part. The examples, I will try to put a picture on. This is clay. It is a mineral of aluminium. This is clay. It is a mineral of aluminium. It is a mineral of aluminium. And for the ores, I have another picture. This is bauxite. This is bauxite. It is an ore of aluminium. It is an ore of aluminium. So you can clearly understand the differences between ores and minerals. Between ores and minerals, both of these contains aluminium. But the fact is, ore, bauxite is called ore because you can extract aluminium profitably from bauxite. But in case of clay, you are unable to extract aluminium profitably or economically. So as from bauxite, it is easier or more economically feasible to extract aluminium. Hence we call this an ore of aluminium, and clay is just a mineral. So with that, I conclude this lecture. Thank you.
In the video, it is properly defined the difference between a mineral and an ore. And for our first activity, minerals have been extracted from the earth since prehistoric times, and the history of civilization and industrial advancement has been linked with man's ability to harness and use the minerals available. Once a mineral deposit has been found, it has been extracted from the ground to access the valuable minerals it contains. Use the idea of this container as layers of rocks. And we have 3 guide questions. Number 1, since we cannot see what underlies beneath, what can you suggest on how minerals can be found? Number 2, what do you think are mineral deposits present in these layers of rocks? And number 3, how will you separate each mineral component? We can answer this question as we continue our discussion. Mining is the process of mineral extraction from a rock seam or ore. Mining refers to the set of processes in which useful resources are withdrawn from a stack of any non-renewable resources. Within the context of earth resources, mining usually refers to the extraction of mineral resources. Mining is of one critical importance to industrialized societies because some minerals cannot be grown, they can only be mined. Mining is a controversial industry because it is usually associated with irresponsible practices. These are the following steps done during mining. Number 1. Prospecting or exploration. Looking for ore body, a deposit that can yield a large amount of required ore mineral. Number 2. Drilling. Extracting a part of the ore to determine the resulting ore, its quality, and the amount of ore minerals. Number 3. Modeling. Determining the ore size, shape, and grade distribution throughout the deposit to apply appropriate mining methods, blast and dig patterns, safety precautions, and efficiency and processing methods. Identifying and assessing the potential impacts. Considering on the social and environmental aspects and finding ways of mitigating if any consequence of mining operation with the purpose of bringing the area back as close to its original state as possible. Number 5. Designing and constructing the mine. Creating the appropriate mine and operational design and proceeding with the construction once all the necessary permits are acquired from the government and local communities. Number 6. Ore extraction. Separation of high-grade ores from the rest of the deposit. 7. Milling. Crushing and concentration of ores, waste materials are released. 8. Mine site decommissioning. Closure of the depleted mine. The mine site is cleaned up and reclaimed or rehabilitated for other purposes. Let's go now to the two methods of mining. The first method is surface mining. It is used to extract ore materials near the surface of the earth. The soil and the rocks that cover the ores are removed through blasting. Blasting is controlled use of explosives and gas exposure to break rocks. In surface mining, it involves removal of plant life, soil, and potentially bedrock to be able to access resources, deposits. It is normally used for fairly shallow and non-precious deposit. The two foremost kinds of surface mining are open pit mining and strip mining. Let us first discuss the open pit mining. This is the most common type of surface mining. Open pit mining means a big hole in the ground. The pit in the mine is created by blasting with explosives and drilling. It is used to mine gravel and sand and even rock. The other one is the strip mining. This mining type involves the removal of thin strip of overburden. The overburden is the earth or the soil. Above the desired deposit, dumping the removed overburden behind the deposit, extracting the desired deposit, creating a second parallel strip in the same manner, and depositing the waste materials from the second strip into the first strip. To better understand what is open mining and strip mining, I have a video clips that can help you understand the two. Let's watch the videos.
This is the Betsy Post Pit, one of the world's largest gold mines. It contains 45 million ounces of gold. They have to mine 10 tons of rock in order to get 1 ounce out. As you can see, it's huge, 2 miles long, mile wide, 2,000 feet deep.
Because gold is so valuable, the extraction of just a few thousand ounces a day pays for this extraordinary mining operation. And removing the gold ore requires drastic action.
Wow. That's what 400,000 pounds of explosives looks like.
Giant diggers work 24 hours a day, excavating over 90 million tons of rock a year, enough to cover Central Park in 55 feet of rubble. But within this raw gold ore, not a speck of gold has ever been seen with the naked eye.
The mystery is, where's the gold? You can't see it. The rocks look really ordinary. The clue to where this gold is hidden is in the internal structure of this rock.
Magnified 500 times, the gold is still invisible. But this rock is an extraordinary lattice of quartz and mud, perforated with strange cavities. In assay labs, rocks are crushed and blasted in a furnace to over 1,800 degrees. And as the liquid rock cools, the minerals begin to separate.
At the end of this process, something extraordinary has happened. An ordinary-looking rock actually contained a grain of gold. At a concentration of about 5,000 times you would normally see in the earth. It doesn't look like much, but this is what they mine every day.
One business in Wyoming that's bigger than ranching and farming combined. Much bigger. And it got to #1 not by reaping enormous profits from what's on the land, but from what's under it. Coal. This fossil fuel got its start millions of years ago, when soggy masses of vegetation were covered by layers of soil. As the soil's weight squeezed the water out, energy-generating carbon was left behind. Carbon in the form of coal. So much coal that it takes some of the largest machines in the world, digging some of the biggest mines in the world, to strip it from the land. To get to the dark veins, huge excavators work 24/7. These machines are called drag lines because their giant shovels are dragged across the mine on thick steel cables to strip away the soil above, known as the overburden. Then it's hauled off and dumped out of the way, allowing the harvesting of the coal itself to begin. Over 100 million tons were extracted here at the North Antelope Rochelle mine in 2012 alone, making this the most productive coal mine in the U.S. And the output here and across Wyoming is on the way up, since coal is one of the world's hottest commodities. There's so much coal in Wyoming, it requires mining equipment so big and so powerful, it boggles the mind. Like this drag line at the Black Thunder coal mine. Its 360-foot boom, 240-ton bucket, and cab the size of an apartment earned it the title Ursa Major, or Big Bear. It cost $50 million and took 3 years just to assemble here on site. The raw power of Ursa Major is astounding. Thanks to its boom, it can swing hundreds of tons of earth hundreds of feet in seconds. Its long dragline cables enable it to scoop up overburden that's 200 feet below the dragline itself. And this one machine is operated by just a single person. Ursa Major's power to tear through the earth gives headaches to environmentalists, but also powers an industry that provides thousands of jobs. Most coal in Wyoming is extracted from the earth in giant surface mines like these. But dig much deeper in the state, and there's even more treasure to be found. Vast oceans of crude oil, thousands of feet underground. It lies below a landscape that's unlike any other in Wyoming. Nearly 35 square miles of land covered by almost nothing but oil wells. This is the Salt Creek Field, one of the longest continuously producing oil fields in the world. One reason the Salt Creek Field can still produce oil today is because companies here are using new technologies to force what remains out of the ground. Crews are busy drilling new wells that use carbon dioxide injection. As the carbon dioxide is pumped into the earth, it forces the oil out. And a controversial side product common to many wells. Natural gas, the oil companies don't want, and merely burn away in flames that dot the landscape. A practice many decry as a waste. Proponents of carbon dioxide injection claim the new technology provides safe and innovative ways to tap a vital natural resource. Foes warn that it could contribute to global warming and poison Wyoming's drinking water. During its big boom, all the oil that flowed out of Salt Creek made its way south to Casper, a city that got its start when Mormon settlers built a ferry crossing over the Platte River in 1847.
The strip mining method is used for coal, phosphates, clays, and tar mining. The other kinds or example of surface mining is the dredging. This is the process of mining materials from the bottom of a body of water, including rivers, lakes, and ocean. I also have a video showing the process of dredging. Let's watch the video.
Rafa, sigue. ¿Qué material está saliendo? Arena, una arenita ahí. Todavía no graba nada.
The second method of mining is the underground mining. It is used to extract the rocks, minerals, and other precious stories that can be found beneath the Earth's surface. Again, the two methods of mining are surface mining and the underground mining. Let us talk about mineral processing. It is the process of extracting minerals from the ore, refining them, and preparing these minerals for use. Let us watch the video.
What is mineral processing? Mineral processing is the process of separating valuable minerals from ore. Imagine you have a chocolate chip cookie, and that is your ore, and the chocolate chips represent your valuable minerals, and the cookie dough is the waste rock. Your job as a mineral processor is to figure out how to extract the chocolate chips in the most efficient manner. But it is not as simple as that. Mineral processors need to have a strong understanding of physics, mineralogy, and chemistry to find the optimal method to process the ore. When you first receive the ore from the haul trucks, you will need to reduce the size of the ore through a series of crushing and grinding stages. This is where the physics and mineralogy comes in. Afterwards, the size-reduced ore will proceed to the recovery stage, where the valuable minerals will be separated from the ore, and usually it is done based on their surface chemical properties. As you gain more experience, you can even venture into different specialties such as process automation, developing nano-drying technologies, or dive into electronics recycling. If you have a passion for physics and chemistry, and you like to design, analyze, and optimize processes, then you should consider a career in mineral processing.
The primary steps involved in processing minerals includes: Number 1. Sampling. It is the removal of portion which represents a whole needed for the analysis of the material. Number 2. Analysis. It is important to evaluate the value component in an ore. This includes chemical, mineral and particle size analysis. The third one is the comminution. It is a process where the valuable components of the ore are separated through crushing and grinding. This process begins by crushing the ores to a particular size and finishes it by grinding the ores into a powder form. And the last step will be concentration. It involves the separation of the valuable materials from the raw materials. Alright. The four primary steps involved in processing minerals are sampling, analysis, comminution, and concentration. We're not going to discuss it in full. Just remember the four primary steps involved in processing minerals. To summarize today's lesson, minerals is naturally occurring substances of metals present in Earth's crust. Ore is a mineral in which can be used to obtain the metal profitably. Mining is a set of processes in which useful resources are withdrawn from a stack of any non-renewable resources. We have two methods of mining. First is surface mining. It involves removal of plant life, soil, and potentially bedrock to be able to access resources deposited. Types of surface mining. Open pit mining. This is the most common type of surface mining. The pit in mine is created by blasting with explosive and drilling. It is used to mine gravel and sand and even rock. Strip mining. This mining method is used for coal, phosphates, clays, and tar mining. Dredging. This is the process of mining materials from the bottom of the body of water, including rivers, lakes, and ocean. The second method of mining is the underground mining. It is used to extract the rocks, minerals, and other precious stored that can be found beneath the Earth's surface. Mineral processing. It is the process of extracting minerals from the ore, refining them, and preparing this material for use. The primary steps involved in processing mineral includes sampling, analysis, comminution, and concentration. I hope you learned a lot for today's lesson. Thank you for listening.